Thank you. Hello everyone and welcome to Where to Win webinar series. My name is Noor Basha, Senior Marketing Manager at Winwire Technologies, and I'll be your moderator for today's webinar. As you see, almost all the logistic details are available on the screen. However, I would like to highlight a couple of them. In case if you experience any audio issues during the webinar, you can dial in through telephone details provided to you in your registration email. Also, please feel free to pose questions and we will try to answer as many as we can at the end of the webinar. So today's topic is on Xamarin.Forms, building cross-platform mobile apps, where we will learn and hear more from my colleague Amit on how to use Xamarin.Forms API to quickly build shared screens for iOS, Android, and Windows Phone. So before I hand it over to Amit, let me introduce a little bit about Amit. Amit Dubey is a Senior Director for Mobility and Cloud at Winwire Technologies and brings over 14 years of experience in the IT industry. And for the last 5 years, he's been working on architecting cross-platform mobile apps. So, and with that, I would like to turn it over to Amit. Amit, over to you.
Sure. Thank you, Noor. Hello and welcome everybody to Xamarin.Forms webinar. We'll see what Xamarin.Forms brings to the table, and then we'll see how we can build cross-platform mobile applications using Xamarin.Forms. So as Noor said, myself, I'm Amit Dubey. I'm the Director for Mobility and Cloud at Winwire Technologies. So what's covered in the session today is basically I'll introduce you to Xamarin.Forms, what is the concept, how it works, and then we'll see some of the advantages of using Xamarin.Forms. We'll talk about how to do data binding with Xamarin.Forms, and then we'll talk on a high level about MVVM architecture and how it works hand in hand with Xamarin.Forms. Then we'll see some of the advanced topics. So we will not go a lot into detail, but I'll explain you like what are the advanced topics like custom renderers and dependency services and how you can use them in your applications. Finally, we'll be showing you a case study, basically one of the projects that we have developed using Xamarin.Forms that has been very successful. So let's get started. First of all, what is Xamarin.Forms? So Xamarin.Forms is a framework that allows developers to rapidly create cross-platform user interfaces. So it provides you its own abstraction of controls and pages that you can use in different platforms, and they will be rendered as native implementations on the respective platform. So it's basically a UI framework that you will get that you can use across different platforms. Like, say for example, you can have it for iOS, Android, on Windows, and you're going to write like one UI code that will be working on all the three platforms. So Xamarin.Forms applications are architected in the same way like your traditional applications. So we'll see how they are different from traditional Xamarin applications. So if you see here, what we used to do with traditional Xamarin is like you used to have a shared C# backend code which used to have all the business logic, the data access, the web service calls that you're making. So everything used to be shared in that project, the PCL or the shared library that you have. Now, as far as the UI is concerned, what we used to do is we used to build separate UI for iOS, a separate UI for Android using activities, and then separate UI for Windows. So you could not combine those into one. So UI used to be separate. Only the business logic or the service calls used to be shared between the different platforms that you're building for. So that was the traditional approach. Now with Xamarin.Forms, what happens is not only you are sharing the backend code that you used to do before, but you can also share the UI code, which means you can build your views using Xamarin.Forms controls that will be rendered as native controls on different platforms such as iOS, Android, and Windows. So you don't have to recreate the views for every platform. So that is the major advantage. So if you used to share, say for example, 60% of the code before, now you should be able to share maybe 80 or 90% depending on your application. So you're sharing the backend code as well as the UI code. So your common code has become more with Xamarin.Forms. But the only difference is you will have a learning curve in like how to create views using forms. But rest everything remains the same. The programming language, C# that you're all familiar with, but you will be using the same programming language to do that. Let's see what are the advantages of using Xamarin.Forms. So as I already said, like you can quickly and easily build native user interfaces using shared code. So any views that you're building can be shared across multiple platforms, and you can easily create them either using C# or using XAML. So C#, it basically depends on what you are familiar with, and depending on ease of use, you can choose either XAML or you can choose C# to build your views. And the most important thing is the Xamarin.Forms elements map to native controls, which means that if I have a input control or a text field on my form, then it is going to be rendered as a native text box on your iOS, Android, or Windows respectively. So if you have a button or label, whatever control it is that Forms provides will be rendered as a native control when you run that application. You can mix and match forms with native APIs. So it's not that if you're writing a forms project or creating a forms project, you are stuck only with forms controls. No, you can still have your native implementation for some of the controls, and you can still have the forms. So you can have both in one project. So it gives you the flexibility of using the native APIs for controls that are not available in forms right now. You can still use the native API. So it's a mix of both that you can still go ahead and use. So let's see what's included in Xamarin.Forms. So you get a number of pages, layouts, and controls that we are going to talk about in the next slides. So you see what are the different views that it supports. As I already said, building views, you can either use XAML or you can use C# if you are comfortable with that. So you can create views in any manner that you like. Then there is two-way data binding available. We'll be talking more about this, like how two-way data binding works in Xamarin.Forms, which basically says that if you change something in your view, then it is reflected in the properties that it is bind to. You have the navigation and rich animation API available that you can use with forms. We have custom renderers where you can create custom controls apart from what forms provides. You have dependency services that you can use to implement functionality that is different for each platform, but you still want to use it in your forms project. And there is messaging center that you can use to interact with the application. So we're going to talk a little more detail about all of these. So let's see what are the pages that Xamarin.Forms provides. So firstly, there are like 5 kinds of pages that you can use for your app. One is a content page, which is a page that displays a single view, which is often a container such as a stack layout or a scroll view. And then there is a master detail page. It's a 2-pane page, basically, where you have a parent-child relationship kind of a thing. So you select one thing in the one pane and the details are shown in the second pane. So that's your master detail page. Then there is a navigation page. And so this one actually manages the navigation and uses a stack of those pages to go like forward and backward. Then there is the tab page. This allows you to put different tabs, and then selection of each tab actually changes the content on the top part. Lastly, there is a carousel page, which is basically similar to a gallery that you can use to show a slides kind of thing, and then you can move backward and forward using this carousel page. So there are a number of layouts available that you can use. First one is your stack layout. Stack layout is basically like you can have it either vertical or horizontal stacks that you can place of controls. And then there is absolute layout that you can use where you can place controls by giving the coordinates. There is a relative layout that you can use. Basically, it aligns with the controls that are placed next to each other. And there is a grid layout that you can use to create columns and rows, those kind of structures. And there is a content view, which is basically one single view that you can use. Content view may not be used as a whole in itself, but it will have more things added to it. There is scroll view that you can use to actually have content that scrolls up and down and then horizontally as well. There is frame that you can use to provide borders around your controls. So those are the different layouts that Forms provides you out of the box. And depending on your application, you can choose the layout depending on the page structure that you're building. Views are nothing but controls that you can place on your forms. So these are the controls that are available out of the box, like a text field or a button or a label. So whenever remember that whenever you put any of these controls on your form, they are rendered as native controls on your platform, respective platform. So when you execute the application. So now let's talk about how you're going to architect a Forms application. Now the recommended architecture for Forms would be your MVVM, which is your model, view, and view model. So I'm going to talk a little more about what is a view, what is a view model, and model. So a view, as we talked about, is nothing but your presentation layer. It contains all your UI elements and your UI logic. So say for example, if I add a form to my project, then what I'm going to do is I'm going to either write it in C# or in XAML. So I'll add all the controls. So that is my view. And then I will add the logic. Say for example, if somebody clicks on a button, then what that button is going to do is your click event that you're going to have in your view. Next is your view model. Now view model is something like your presentation logic. Say for example, you can have properties and commands in view model that are bound to your view. Now, which means that when some user interaction happens on the view, you can invoke a particular method or bind it to a property in your view model. We are going to see more about how data binding works and how commands work as we move forward. But for now, just think that you can have commands that you can bind to your view. So we're going to talk a little more detail as we move forward. Now, in your MVVM architecture, like how it works is like your view actually knows about the view model. So it knows what view model it is working with, and it binds all its controls to the properties of your view model. But view model is like completely independent. That logic has to be independent of the view. So the advantage of this is that you can use any view with this view model. So it should be independent of the view that you're working on. So if you see the slide, then I'm having like multiple things of the view, which means that the view model can be used with multiple views. The advantage here is that say for example, if you want to have a different representation on different platforms or different form factors, then you can use this model, because your logic will still remain the same. Your UI elements may be formatted in a different manner. The presentation could be different, but the logic still resides with the view model that can be used in multiple views. So that is one of the advantages of MVVM. And model is finally your business logic and your data and your business objects. So say for example, if I'm working with an employee object, so that will be a model that your view model will be using to display on the view the details. And the model can have all the logic, like whether it is valid or not. It can have methods to save the data and fetch the data and stuff like that. So that is how you will be structuring your Forms project. So you have views, which are your presentation, and then you have view models, which is your presentation logic, and finally your models, which are your business objects and data. Now let's talk about data binding. What is data binding and how you're going to use it. So say for example, if I have a text field or a label on my view, and if I have to show a value in those fields, and then whenever the user changes that value, I want to send it back to the server. how these things will work is by using data binding. So if you see here, the first box on the left side is actually implementing an interface called as iNotifyPropertyChanged. So we recommend that all of your view models actually implement this. So you can create a base model that implements iNotifyPropertyChange and use that base model in all your view models. So basically what you're doing there is you're just raising an event called property changed, and then you're passing the name of the property that just got a new value. That's your iNotifyPropertyChanged. And if you see the implementation of the property, which is the second box on the right side of the slide, you see that we have declared a property called first name in the view model, and then whenever the value of this property is changing, so if it gets a new value in this first name, what we do is we call the event on property changed, and then we tell which property this is. So what happens is when you have your view model in the view, what you can do is you can say view model.on property change. You can have an event, and whenever the property changes, you get notified. So if you have to do something on the view, depending on the property, you can write that code on property changed event. So how do we bind this first name property with the control on my view now? So if you see the last box at the bottom of the slide, how it is binded is like you create a label called first name, and then you set the binding. Now in the set binding method, you have two values, two parameters. First is which property you're binding it to. So you say label.text property, which means I'm trying to bind the text property of this label and to which property, which is the first name property from my view model. So the label will always get the value from the first name property of your view model. So if somebody changes the value in the view model of first name property, then the same thing will be reflected on the view automatically. So that is your two-way data binding. So say for example, if this label would be a text box, then if the user types something in the text box, then the view model will have that value in the first name property. So it goes both ways, from the view model to the view, and then the view to the view model. So that is how you bind the properties of your views with view model. Coming to commands, now as you see, you can bind the properties, static properties that can get values from the view model. Now say for example, if I want to execute some function when the user clicks on a button, how would I do that using the view model? So what you have to do is you have to define a command in your view model that will have the logic to say execute something when the user clicks on a button. So say for example, we are having a login button now. I define a login command in my view model, and I write the logic in the execute login command function here. So now how do I use this function in my view? So how do I bind my button with this particular function that I've written in the view model? So this is how it happens. So if you see the bottom box on the slide, what we are doing is we are creating a button, a new button, and then again we are calling the set binding function that we used with the label in the previous slide. But what is different here is we are binding the command property of the button. So the button will have a command property, which is nothing but your tapping on the button event, like click event, and then I'm binding it with what? Login command. This is the command that I declared in my view model. So whenever the user clicks on this button, automatically the login command will be executed that you have written in your view model. So that is how you bind the properties, and that is how you bind the commands on the controls between views and view models. So that's about your basic structuring of MVVM. Now let's talk about custom renders and dependency services. Now these are some of the advanced topics in Xamarin.Forms. So this is what separates experts in Xamarin.Forms from basic users. So if you have come to the level of writing custom renders and dependency services, you could call yourself an expert in Xamarin.Forms. They're not very complex, but they're very useful actually, because forms is still evolving, and you may hit a number of scenarios where you may have to write a custom render or a dependency service. So let's see what a custom render is. So what it does is it allows you to change the default behavior of of a particular control. Now Xamarin.Forms has actually written its own renders that it uses to actually render the control on the native platform. What you could do is you could override the behavior. You can override the behavior for any platform by using custom renders. Similarly, dependency services are something like where you want to have some code or functionality that is not available in Forms because it is different across platforms, but you can still have it in your Forms project by creating services. So we'll see both of these in a little more detail in the next slides. So let's talk about custom renders. So custom renders, say for example, I'll give you have a button that you want to create with a red color border. Now what Xamarin.Forms promises you is that if you create a control from Xamarin.Forms, it will be rendered natively on the native platform, I mean corresponding platform. But what it does not promise is it will support all the properties of any control. So there might be some properties that are still not supported by Forms. So say for example, border color. Now if you give a border color to the button, it will appear properly on iOS, but you will see that the color is not appearing on Android and Windows Forms. So what do you do in this case? You do want the border color to appear on all the platforms. So in this case, what you can do is you can write a custom render. You can write a custom renderer to apply this property, to the button on Android and Windows. So if you see here at the top, you have the button class, and then it has different renderers for each platform. Now you can go ahead and write a separate implementation for each of these, for Windows, Android, and iOS. So in your renderer, you can have the custom attributes that you want. You can apply all of those to the button in that platform, and then it is finally rendered on the screen. So this way, what you can do is you can customize any control that Forms provides by writing your own renderers to it. So if there is any control that is not supported, or any control whose properties are not supported, the answer for that would be to create a custom renderer. Next we will see what is a dependency service. So as I talked about, say for example, if you have some functionality that you want to provide which is not available in Forms because it has a different implementation in each of these platforms. Say for example, if I want to read files, then the file system works very differently on all the three platforms. So you cannot have common code in that case. But how do I use it in Forms then? So dependency services come into picture in this scenario. So what you will do is, there are three key elements to creating a dependency service. First is an interface where you're going to create an interface, basically a file, class file, a file that has the methods that you want to implement. Say for example, if I want to read a file, so I'll say read file, and then I'll have a parameter with the path of the file or name of the file, say for example. So that is my interface with just one stub method, which is read file with the path. Now, then the second step for you is to register this. Now, how will you register this services? Like in each platform, what you do is you implement the interface that you just created. So in iOS, I'm going to implement the same interface. I will say read file, and I'll write all the logic in the iOS, and I'll write the same logic in Android and Windows. And then I have an attribute that I will use to bind this service, to basically say that this is a registered service. So I use a special attribute that Xamarin.Forms provides, and then this service will be registered in each of those platforms. Now I have the interface, I have the registration. Now interface will be something that will be there in your shared project, and then registration will be across the platform project. So there where the implementation of this interface will be residing. Lastly, the location. Now I want to use this service that I just created. I created an interface, I wrote the implementation, and I want to use it. So how do you use it is, the thing is, you have the service locator functionality where you will say, get me an instance of this interface. So when you say that, what internally Xamarin.Forms does is, like when you provide the interface, it sees whether there is an implementation for that interface in that platform, which is a registered service that we created. So what it will do is it will fetch that service, it will create an instance of that service and then give it back to you. So then you can use all the methods in that service as if you're using a normal class. So that is how the dependency services work. So you have to create an interface, you write the implementation in a respective platform, you use the service locator to get the class and then work on it. So that way you can have functionality that is not available in Forms, still use it in the Forms project. Now let's see what we have done in Forms as one of the projects that I'm going to talk about. So here we work for a solar company that used to build microinverters. Now what they wanted was they wanted to build an app for iOS and Android what could be used by their installers when they go to a particular site to install the microinverters, the solar powered microinverters. They have to place all the microinverters in a particular grid fashion, and then they have to submit this information to the server. Now, because we wanted to build it quickly using Xamarin.Forms for iOS and Android, so what we did was we used the MVVM architecture, and then we had created an application that is common for iOS and Android, and then we had support for localization in 4 languages. We had offline support for this. Everything was done in Xamarin.Forms, and because the team was already familiar with C# and they had knowledge of working with traditional Xamarin, there was a very small learning curve that we had to go through for Forms of creating the views, but then it was a very successful app that we already have, which is being used by a number of installers for this company right now. I'm going to show you some screenshots that you can see for this application. This is the iOS version of it, and then this is the Android version. So if you see, like, everything has been created using one views, so they are rendered as native controls on iOS and Android. So that's all I wanted to cover in this session in the limited time that we had. I hope you got a high-level introduction to Xamarin.Forms and how it works. I'll pass it over to Noor, and if you have any questions, then do please let us know. Noor?
Hello, Amit. You can hear me, right?
Yes, I can. Thank you.
Yeah. Thanks, Amit. Thanks for the wonderful session. I hope all the audience enjoyed here, which helped them to know more about Xamarin.Forms. Yes, there are a few questions. I know in the interest of time, we will quickly jump in and take a few questions before we wind up the session. So there is a first question coming from the Mark, who says, how to create separators in Xamarin.Forms?
Noor, can you please repeat the question?
How to create separators in Xamarin.Forms?
Separators, I'm not really sure what separators mean here. Basically, if you're talking about creating different implementations for different controls, then as we talked about, you could use custom renders or dependency services for that. But I'm not sure if I'm really understanding the question correctly. But I can certainly get back to you on that if you reach out to us over email.
Sure, I think that will be helpful, Amit. We will definitely do that. We'll just jump into and take a couple of more questions. The other question which comes is, does Xamarin support shared projects?
Yes, it does. I mean, as you've been using it with traditional projects, Xamarin supports shared projects as well as your portable compact library. So you can use both of them with Xamarin.Forms.
Great, thank you. And I have the question, which again, does Xamarin work with SQLite?
Yes, Xamarin does work with SQLite. I mean, you have a library, SQLite.net, that you can use for both iOS and Android simultaneously without writing any additional code for each of these platforms.
Great, thank you. So let me take one last question for the day. So how do you write platform-specific code in Xamarin.Forms?
Yes, the answer for that is either you use custom renders where you are writing custom controls where you will be writing implementations as you used to write in traditional Xamarin applications.
Okay, thank you, Amit. I know we are already running out of time. So what I would request audiences is that in case if you have more questions, you can write in your questions to marketing@winwire.com, and we will have Amit respond to those questions as soon as possible. Thank you, Amit, for the wonderful sessions. Thank you, audience, for joining this session. I hope you enjoyed it. Have a good day.
Thank you, Noor. Thank you, everybody.